So imagine this. What if the giant T-Rex had a sort of unexpected grandmother? Not some other huge predator, but maybe something uh, quite different.
Mm.
That's kind of the mystery we're digging into today with Aviatyrannis jurassica, a dinosaur from the late Jurassic.
Right. It's a fascinating one.
We've got scientific reports here tracking its discovery, its classification,
Mm.
which seems to keep changing. So our mission really is to figure out why this pretty small dinosaur is causing such a stir.
Absolutely. And it's amazing how just a few fossil fragments can make us rethink, the bigger picture of how major dinosaur groups evolved. The story of Aviatyrannis in these reports is, well, it's a perfect case study in how science revises itself.
Okay, so this grandmother idea, where did it actually begin? Where did Aviatyrannis first turn up?
It all started in Portugal at the Guimarães coal mine near Leiria.
A coal mine.
Yeah, and back in 2000, the paleontologist Oliver Rohut first reported some theropod fossils found there. Initially, he thought they might belong to Stoxosaurus, another known dinosaur.
Ah, okay. So for a bit, it was potentially lumped in with something else.
Exactly. But Dr. Rohut kept studying them. And by 2003, he figured these Portuguese fossils were distinct enough to be their own thing, their own genus.
And that's when Aviatyrannis jurassica got its name.
That's right, 2003.
Aviatyrannis jurassica certainly sounds significant. What's the meaning packed into that name?
Well, it's pretty direct, actually. Avia is Latin for grandmother,
Oh.
and tyrannus means tyrant. So the idea, or maybe the hope, was that it could be the tyrant's grandmother.
Hinting at a link to T-Rex and its relatives.
Precisely, an ancestral link, and Jurassica just places it in the Jurassic period. So yeah, tyrant's grandmother from the Jurassic.
Wow, okay. That's quite a claim to bake right into the name.
Mm-hmm.
So what physical evidence, what fossils do we actually have for this potential ancestor?
The key piece, the one that defines the species, that's the holotype, it's a right ilium, IPFUB KT1 is its catalog number.
The ilium, that's the main hip bone, right?
Yeah. One of them, yeah. Like crucial one for posture and movement. And it came from the Alcobaça Formation. Dating-wise, that's early Cambrian stage, late Jurassic. So roughly 155 million years old.
Just the one hip bone. Seems like maybe not a lot to go on for such a big idea.
Well, it is the holotype, but there are a few other bits referred to it. There is IPFUB T2, another partial right ilium, but from a slightly larger animal.
Okay.
And IPFUB T3, which is a right ischium, another hip bone again, seems to be from a larger individual.
Right.
And then there were those 16 isolated teeth. They were actually described a bit earlier in 1998 by Jen Zinka.
Ah, the teeth. Do they give us any specific clues?
They do, yeah. Especially the 3 premaxillary teeth. Those are the ones right at the front of the snout.
Uh-huh.
If you cut them across near the tip, they're not round. They're kind of D-shaped, flattened on one side.
D-shaped. Interesting.
Yeah, and they have these tiny serrations, denticles, running straight across both edges. Circular base, somewhat flattened crown top, little details, but really important for comparing them to other theropods.
You also mentioned Dr. Rauhut thought some fossils, maybe previously assigned to Stoxosaurus, might actually be Aviatyrannis. How does that work?
It really just shows the challenge, doesn't it? Working with incomplete stuff. Sometimes isolated bones or teeth look similar across different but related species.
Right.
So Dr. Rauhut probably saw enough overlap, plus the unique features he saw in the Portuguese material, to suggest, well, maybe some other bits were misidentified. It's like sorting out jigsaw pieces.
Okay. So we have these hip fragments, these teeth. What does it tell us about what Aviatyrannis actually looked like? Was it like a mini T-Rex?
Based on what we have, it was pretty small, a small theropod. That holotype ilium is only 90 millimeters long.
90 millimeters, so less than 4 inches.
Yeah, tiny. Gregory S. Paul, back in 2016, estimated maybe a meter long, about 3.3 feet, and weighing maybe 4 kilos or just under 9 pounds.
Wow. So like the size of a medium dog, maybe?
Something like that, yeah. And Paul also suggested the holotype might even be from a juvenile.
Ah, so adults could have been bigger.
Possibly a bit bigger, yeah. But definitely not a giant. A small predator.
And the shape of that hip bone, the ilium, did that reveal anything else crucial?
Yes. The morphology, the shape, is key. It's described as long and low. And importantly, it has this vertical ridge on the outer surface, right above the hip joint area.
A ridge. And that's significant because,
Because that specific kind of ridge is a feature often seen in early tyrannosauroids.
okay. So that fits the tyrant's grandmother idea.
It was definitely one of the main reasons for that initial classification, along with some other details, and those D-shaped teeth also fit to some extent.
Right. Which brings us neatly to the classification debate. Rauhut put it as a basal tyrannosauroid back in 2003. What does basal mean here, and why was that a big deal?
Think of it like a family tree or maybe a bush. Basal means it's on one of the earliest branches to split off from the main stem.
Okay, near the beginning.
Exactly. So classifying it as a basal tyrannosaurid meant Rauhut was proposing it was one of the oldest, most primitive members of Tyrannosauridae, the big group that eventually includes T-Rex.
So potentially one of the very first steps on the road to Tyrannosaurus.
Potentially, yes. If correct, it would be one of the oldest tyrannosaurids found. Maybe only Proceratosaurus or Iliosuchus could be older, and their status is, well, also debated. So it was like opening a window onto the very dawn of the tyrant dinosaurs.
A crucial piece of the puzzle. But the story didn't stop there, did it? There's been more recent thinking that suggests a very different branch of the family tree.
That's absolutely right. Things got really interesting in 2023 with a paper by Hattori and colleagues. They looked closely at that ilium again, and they saw some striking similarities, not to early tyrannosaurs, but to a dinosaur called Tyrannosaurus.
Tyrannosaurus. Okay, never heard of that one. What group is that in?
Tyrannosaurus belongs to the Dinocaridae.
Dinocaridae. Okay,
Yeah.
bit of a mouthful. Remind us what they are.
They're part of the Ornithomimosauria, the bird mimic dinosaurs.
Ah, the ostrich dinosaurs.
Sort of, yeah. That group includes the ostrich-like ones, but also these dinotirids, which were, well, weirder. Think Dinocaris itself, with those huge arms, the humpback, the duck-like build.
Oh, right. Very different from T-Rex. Weren't they mostly herbivores or omnivores?
Many seem to have been, yes. A big contrast to the hypercarnivorous tyrannosaurs we were just talking about.
So hang on. This 2023 paper is suggesting that the tyrant's grandmother might actually be related to these bird-mimicking, possibly plant-eating dinosaurs.
That's the proposal, yeah. It's a pretty major plot twist.
What led them there? Just the hip bone again?
Primarily, yes. Hattori and his team argued that despite the features Rauhut noted, the overall shape and some specific unique characteristics of the Aviatyrannis ilium looked remarkably similar to the ilium of Tyrannosaurus.
Huh.
Their detailed comparison opened up some really unexpected possibilities for where Aviatyrannis fits.
Like what? What were the options they considered?
Well, one idea was that Aviatyrannis could actually be the earliest known ornithomimosaur, like the very root of that whole bird mimic group.
Wow.
Or, perhaps even more surprisingly, maybe the earliest known dinocarid, putting it right at the origin of that specific unusual family.
Okay, those are radically different ideas from Tyrant's grandmother. How do they test these hypotheses?
They used phylogenetic analyses. These are complex studies where scientists code lots and lots of anatomical features from many different dinosaurs and then use algorithms to figure out the most likely evolutionary tree based on those shared features.
Like a computer building the family tree based on the evidence.
Essentially, yeah. It's a way to test relationships more rigorously.
And what did their analyses spit out?
Well, one analysis actually placed Aviatyrannis as the closest relative, the sister taxon, to Tyrannomimus, right there with the dinocurids.
Oh, kidding.
And another analysis also put Aviatyrannis firmly within the Ornithomimosauria, the broader bird mimic group, but maybe in a slightly earlier branch, before the Dinocaridae and the more classic Ornithomimidae split.
We have a cladogram here, sort of a visual of that family tree from Hattori's research. And yeah, you can see it. There's Aviatyrannis sitting right next to Tyrannosaurus. Way over here with Dinocaris, Harpyminus, and far from the branch that would eventually lead to Tyrannosaurus.
Exactly. That cladogram shows visually just how different this interpretation is. It pulls Aviatyrannis away from the Tyrannosaur line and places it potentially deep within the history of these bird mimics.
It's just incredible how one bone, looked at, again, decades later with new comparisons, can lead to such different conclusions. So where does that leave us? Is it the tyrant's ancestor or an early bird mimic?
The honest answer is it's still debated. It's an active area of research.
Right.
Rauhut's initial idea made sense with the evidence then, but Hattori et al.'s work presents a really compelling alternative based on those detailed ilium comparisons. They themselves say, you know, we really need more fossils, more complete skeletons would be ideal to settle it.
So this little dinosaur from Portugal is kind of a linchpin, isn't it? It could unlock secrets about the early days of, either the Tyrannosaurs or the ornithomimosaurs.
Precisely. It's a fantastic example of how science progresses. New finds and new analyses of old finds. They constantly make us refine the picture.
Okay, so let's quickly recap our deep dive. We've got Aviatyrannis jurassica, late Jurassic, Portugal, found in a coal mine, initially named Tyrant's grandmother, and seen as a very early tyrannosauroid based on features like that ridge on its hip bone.
Right.
But more recently, scientists have highlighted strong similarities in that same hip bone to Tyrannosaurus, suggesting it might actually be an early ornithomimosaur, possibly even the oldest known dinocarid part of that weird bird-mimic group.
That sums it up well. It's a story of shifting interpretations based on careful analysis of limited but crucial fossil evidence.
It really is. And it leaves you with a fascinating thought, doesn't it?
It does, and maybe something for you listening to ponder. How does changing the identity of just one relatively small and obscure dinosaur like Aviatyrannis actually affect our understanding of the really big stories in dinosaur evolution?
Yeah.
Think about how placing it with ornithomimosaurs instead of tyrannosaurs might force us to rethink the very first steps, the primitive traits that led towards giants like T-Rex and towards the very different bird mimics like Gallimimus or Dinocaris. It shows how interconnected everything is and how much the picture can change with just one key discovery or reevaluation.